Today's lesson is our first lesson on graphical analysis, which is the beginnings of a new unit in calculus. Basically, this unit is going to focus on not how to find derivatives. We've already learned how to calculate derivatives of various types of functions, but what those derivatives can be used to tell us about graphs of functions. They give us a lot of beneficial information. So today's focus is going to be on the first derivative test. And hopefully you've already gone through the note cards for this section, so you're a little bit familiar with some of the vocabulary and how we find some of these important features using derivatives. Let's begin with our first example, which is f of x equals 1/3 x cubed minus x squared minus 3x plus 4. And this is going to be a two-part problem. Part A is going to be determine the critical values. So from our note cards, you should have found out that a critical value or a critical number is a place where the first derivative is either equal to 0 or undefined. Now, we're going to look at our first derivative, f prime of x. So, using the power rule, 3 times 1/3 would be 1, x, subtract 1 from the power squared, and then minus 2 times 1 would be 2 for the coefficient, x to the first power, subtract 1 from the power, minus 3. Okay, so that's our derivative. Now, is this derivative ever going to be undefined? No, that's a parabola. It's defined for all real values of x, so we don't have to worry about that. But it could be equal to 0, so we're going to set that first derivative equal to 0. And is it factorable? Well, we hope so. By the way, any of these problems can be found on the calculator portion or the non-calculator portion, as with anything else we do all year long in calculus. So you need to be prepared to do it either way. So x minus 3 equal to 0 and x plus 1 equal to 0. So that means our critical values would be at x equals 3, and at x equals -1. We have two critical values or critical numbers for this function. Alright, now let's go on to part B. Part B for this function, which I'll copy again, f of x equals 1/3 x cubed minus x squared minus 3x plus 4, and we already figured f prime of x was equal to x squared minus 2x minus 3. We are going to determine the open intervals on which f of x is increasing and decreasing. Alright, so we learned that you can determine from your note cards that a function is increasing if the first derivative is greater than 0, which means it's positive. So it's increasing when f prime of x is a positive number, and it's decreasing when f prime of x is a negative number. Okay? So if I were to set up a number line for this function, and put my critical values on it, which were -1 and 3. We figured those out from the last part A of this problem. All that we need to do now to figure out when that first derivative is positive or negative is test one value between and beyond each critical value. So, for example, I'm going to want to choose a number smaller than -1, between -1 and 3, and greater than 3. Those could be any number that I want. Nobody's going to tell you which numbers to choose. You have to choose yourself. Obviously, you want to choose the easiest number that it would be to do the arithmetic work with, especially if you're doing it without a calculator. So, a number smaller than -1 might be -2. That would be the first one I want to test. One between -1 and 3 that's usually pretty easy to plug in would be 0. I might have chosen 1 instead. It doesn't matter. Any number in that range is fine. And I need a number bigger than 3, so I'll just choose 4. So these are my three numbers that I'm going to test. So how does this work? I'm going to take f prime, which was my derivative, of -2, and find out if this is a positive or a negative number. So I'm going to plug -2 into my first derivative function from above. -2 quantity squared minus 2 times -2 minus 3. Be sure to use adequate parentheses to make sure everything comes out correctly. So this would be 4 plus 4 minus 3, which equals 5. And honestly, we don't even care what this number is. All we care about is its sign, so it's positive. Okay? That means every value smaller than -1 on my first derivative is going to become a positive quantity. Now I'm going to do f prime of 0. Oops. This stylus is so difficult to use. Okay, 0 squared minus 2 times 0 minus 3 is equal to -3, which again, I don't really care about the number itself, but only the sign. It's negative, that's what matters. So I have negative values for my first derivative between -1 and 3. Lastly, f prime of 4 is equal to 4 squared minus 2 times 4 minus 3, which is 16 minus 8 minus 3, which is 5. And that's going to be, again, a positive quantity. Okay? So, now I have all the information that I need to answer the question. So, where is this function increasing? And notice it does say open intervals, which means we're going to use parentheses, not brackets. We're not including the endpoints here. So, where is my function's first derivative going to be positive? Well, that's going to be where my x values are smaller than -1. So from -infinity to -1. And where my x values are greater than 3. Okay? These numbers are the only numbers I'm going to be using in my brackets. These ones that I chose were kind of randomly chosen. They don't belong in there, in the parentheses at all. So we go from 3 to infinity. And if you want to put a little nice union symbol there in the middle, you can. That's not required, but it is a little bit more accurate. Okay. Decreasing. Where is my function decreasing? Well, that's this area where I came up with a negative first derivative from -1 to 3. And that's the answer to that problem. Okay. Next example. Number 2. F of x is equal to 2/5 x to the 5th minus 3/2 x to the 4th plus 4x squared. Problem A, determine the critical values. Okay, so like we did before, we're going to figure out what that first derivative is. Power rule, 5 times 2/5 is going to give me 2, subtract 1 from the power, that's going to be x to the 4th. Now 4 times 3/2 is 6, x to the subtract 1 from the power 3rd, plus 2 times 4 is 8, subtract 1 from the power, that's x to the 1st. So there's my first derivative. I'm going to set it equal to 0. This is a polynomial. It's not undefined anywhere, so we don't need to worry about any undefined values. It's defined for all values of x. And now I'm going to look at, is this thing factorable? Well, I can see that it has a greatest common factor for all three of these terms right now. 2 goes into each term, also x goes into each term. So that would leave behind x cubed minus 3x squared plus 4. Okay, now, how about this cubic trinomial in the parentheses here? Is that factorable? Well, you're going to have to pull out your good old Algebra 2 skills, and you probably went over this again in pre-cal last year. It is indeed factorable, and you might be able to factor it by hand, but it's probably easier to do using synthetic division. If you were to divide something out by synthetic division, your coefficients would be 1 for the x cubed, negative 3 for the x squared. You have to put a 0 placeholder in for the linear term. There is no coefficient of just a plain x in this polynomial. And then 4 would be your last one. Now, how are we going to know what to divide by? Well, I can tell you that if this is a problem you're doing by hand, which this very well could be, they're generally not going to give you any factors that are too terribly difficult to divide out, too large to seek for. I usually try 1 and negative 1 first, and then maybe 2 and negative 2, and that's going to get you at least one of them. Because I did this problem ahead of time, I'm going to go ahead and tell you that negative 1 is going to work. Sorry, spoiler alert. Bring the 1 down, multiply 1 times negative 1 to get negative 1, add vertically, multiply diagonally. Negative 4 times negative 1 is positive 4. Add vertically, multiply diagonally. The last number will be the remainder. So a remainder of 0 means it divided out evenly. So we have 0 equals 2x, that was already here, times, what does this negative 1 mean the factor is? X plus 1. Remember that the 0 is always the opposite sign of the way we see it in that linear factor. And then that leaves behind, from these coefficients, the first one is going to be, let's see, x squared minus 4x plus 4. Okay? Now, is that quadratic trinomial factorable? Yes, and that's going to be a lot less work than factoring the cubic trinomial we just had. X, factors of 4 that add to make 4 would be 2 and 2, both negative. Okay, so what are the critical values? They are x equals 0, negative 1, and 2, and that's from setting each one of these factors equal to 0. Now, It wouldn't be wrong to write the number 2 twice, but it's redundant because x equals 2 is a unique number, so it's not really necessary to write it twice. Okay, we're ready for part B. Okay, part B is going to be classify the critical values as relative minimums, relative maximums, I'm abbreviating, or neither. Now, from your note cards, you should have seen that a relative maximum is when your first derivative changes signs from negative to positive. And conversely, a local, oh wait, I think I read that wrong. Yes, sorry. A minimum, here I'll write it down. A minimum is going to be when the first derivative changes from negative to positive. That means that it was decreasing and now it's increasing. Okay, so we find a minimum when that happens. A relative maximum is when your f prime of x changes from positive to negative. So I was increasing and now I'm decreasing. That gives me a maximum point. Now, if f prime of x goes from positive to positive or negative to negative and it doesn't change signs, then that would be a neither situation. And that is possible for that to happen. So, how are we going to figure this out? Well, let's see here. We're going to start with a number line and we're going to put our critical values on it. Our critical values from part A were at 0 and -1 and at 2. So I just need to figure out where is this function increasing or positive, where is it decreasing or negative. So that means I'm going to choose a number between and beyond each critical value, plug them into the first derivative, substitute them in to find out the sign of the first derivative. So smaller, -2, between -1 and 0, well, unfortunately the best thing I've got there is -1/2. Between 0 and 2, 1, and beyond 2, 3. So I'm going to plug each one of those 4 values into my first derivative to determine the sign at each. So f prime of -2. That's going to be 2 times -2 to the 4th power minus 6 times -2 cubed plus 8 times -2, which is 32 plus 48 minus 16, which is a positive. Like I said, I don't really care what the number is, I just care what the sign is. So at -2, I'm positive, that means I'm increasing there. F prime of -1/2. This one's the one that'll be the most annoying to plug in because it's a fraction, but we can do this. 2 times -1/2 to the 4th power minus 6 times -1/2 cubed plus 8 times -1/2. Alright, where's my good arithmetic thinkers here? This is something the AP exam could ask you to do without use of a calculator. So, -1/2 to the 4th power, well that's definitely going to be a positive, and then times 2, that's going to come out to 1/8, ugly looking 8, and then -1/2 cubed times -6, that's going to be a positive 3/4. And 8 times negative 1/2, negative 4. So, is this going to be a positive or a negative? Negative. Alright, 1. Plug in 1. I'm hoping I can squeeze this here. F prime of 1 is equal to 2 times 1 to the 4th minus 6 times 1 cubed plus 8 times 1, which is 2, minus 6 plus 8, which is a positive. And now last, ooh, can I fit it? Oh, that was the wrong thing. F prime of 3 is 2 times 3 to the 4th power minus 6 times 3 cubed. This would be a lot easier on the whiteboard. Plus 8 times 3 equals 162 minus 162 plus 24. That's going to be positive. Okay, so looking at this information that we've just gotten, before I'm at negative 1, I have a positive slope. Then it's 0, and then I have a negative slope. So negative 1 would be classified as a maximum. Okay? Now, I have, before I'm at 0, negative first derivative, which means I'm decreasing. I hit 0. After that, I have positive first derivative, which means I'm increasing. So at 0, I would classify that as a minimum. Now, at the critical number 2, I have positive slope before it. I hit 0, but then I also have positive slope again. So there might be a little jog in the graph there, but it's not going to turn around and go the other direction. That means that at 2 it is neither a maximum or a minimum. Now, this problem said to classify the critical values as relative mins, maxes, or neither, which we've done, so we are finished. Sometimes they might ask you to find the points themselves that are relative minimums or maximums or neither. In that case, I would take these 3 x values, plug them back into the original function, and solve for the y that goes with them. Not in the derivative, but in the original function. Now, I think that pretty much covers everything that we've got in our lesson today. Critical numbers increasing, decreasing, relative or local minimums and maximums. I did introduce the term extrema or extremum in your note cards. Extrema are it's just a fancy word for mins and maxes. Sorry, I'm writing really sloppy. An extremum would be the singular of that, just one maximum or minimum. And then the last note card that y'all had today is the first derivative test, which is kind of like the title of the lesson. The first derivative test just says that if f prime of x goes from positive to negative, so increasing to decreasing, we have a maximum. And if f prime of x goes from negative to positive, so decreasing to increasing, we have a minimum. So it kind of makes sense when you look at what does that look like on a graph. Your assignment today is a worksheet. I am going to tell you there are a few challenging problems in there. Answers and solutions will be posted on my website, so hopefully you can try them on your own, see how they go. If you have questions, take a look at the work that I'm posting. I'm sure that can help you resolve any issues that you may have. Good luck! Bye!